Hello again, everybody, and welcome back to Good to Know, our food safety and sanitation series, where we focus on how to grow, how to process, how to make, and how to consume food safely. Today's focus is on processing, and specifically processing produce. So, with our expert panelists today, we're going to take a deep dive into how to best process produce. As always, we've got our guest host, Dr. Darin Detwiler, with us. And today we also have a special guest, Dr. Juhi Saxena, with us. First of all, I'd like to introduce Dr. Detwiler allow Dr. Detwiler to introduce himself. So, Darin, over to you. How are you today?
Good, good. Thank you for having me. I'm Dr. Darin Detweiler. I am a professor of food safety and food policy. I'm an author, a keynote speaker, a podcast host, and guest, and I'm proud to be collaborating with PathoSans as a consultant and helping, bring about better awareness and support in terms of making sure that, uh, you know, it's one thing to have a great solution. It's another thing to make sure that people understand, uh, how important this is and why this is important. And so, anyway, thank you for having me.
As always, great to have you, Dr. Detwiler. And then, as I mentioned earlier, we also have Dr. Juhi Saxena with us. Juhi, would you like to introduce yourself?
Thanks, Ken. Thanks for having me over here. I am Dr. Juhi Saxena. I have worked as a scientist for PathoSans for more than 4 years and been in the agri-food industry as a research specialist for over a decade. And it's absolutely wonderful to actually be a part of something that is more about spreading awareness about food safety and quality issues that we are facing in the market today. And absolutely look forward to having a good conversation with you guys.
Wonderful. Today's episode, we are going to be focusing on an area that I know is near and dear to your heart, Julie. We're going to focus on produce and some of the dangers that we see when we're growing, consuming, storing produce all along the way. So, this is just another continuance in our educational series of food safety and sanitation. So, as a representative of PathoSans, we are a leader in safe and sustainable cleaning and sanitation products. So this is right up our alley. So with that being said, I'd like to move right into our first topic. So let's talk a little bit about the pathogens and dangers that are inherent in the growing process. What are our problems? Or I'm sorry, what are our risks? So with that, I'll turn it over to you to start, Dr. Julie.
The pathogens that we normally encounter when we are dealing with fresh produce would be E. coli, Salmonella, Listeria, and the likes of those. And one of the major problems that we see when we are dealing with fresh produce is it's not, it gets readily spoiled, but it's just that by the time we actually discover that the product is spoiled in terms of loss in texture or loss in color, it's very hard to recover from. One of the reasons how these pathogens actually come to be on the surface of the product is either you have insects that carry these pathogens with them, or you have irrigation water which has not been treated properly and is being used in the cultivation of these fruits and vegetables, or there are, fruit flies, for example. They carry species like rhizopus with them, which is a very common microorganism that causes soft rot in fruits. These are some of the factors how actually spoilage occurs in these fruits and vegetables. So one of the reasons how these can actually proliferate is if we provide them the perfect temperature and relative humidity. So what happens when we have, an agricultural farm that's growing some sort of apples and mangoes, and what they do is they just pack them into large boxes and they transport it over to the industries, and where, during transportation there are some sort of vibrational damage that's occurring, some sort of mechanical damage that happens when there is manual handling of products. And that damage actually gives access to these microbes to actually enter the produce. And once they enter the produce, that's where all the spoilage happens. So this is how these have been posing a danger to the growing produce and contributing to post-harvest losses, which our farmers have been, the farmers have been, facing over the past couple of decades.
Well, Ken, I think it's important to add too that you know when we look at the current era of food safety, 30 years ago we were talking about meat and poultry. We weren't talking about produce nearly as often as we were again with meat and poultry, and we've seen a significant shift, not only from the USDA in terms of the foods they regulate. But when you look at outbreaks and you look at recalls, you tend to see today that there's more that comes from foods that are regulated by the FDA, which would include the fruits and produce. Along the way, one of the things that we've seen is that industry has taken more steps to make sure that we can extend the harvest, that we can have access to seasonal fruits year round, seasonal produce. Um, we're getting produce from further distances away because we want it in this market, even though it's not available in this market. And what is end up happening here is that we also have a much more diverse and complicated supply system. You know, last year I was in the documentary Poisoned, and it starts off talking about 1993 with meat. At the end of the documentary, I'm asked what are the foods I avoid today, and those foods are cantaloupe, sprouts, traditional sprouts, that is, and bagged leafy greens. All three examples of produce that we see over and over in the news in terms of recalls and outbreaks. So it's not exactly as if this is a small problem. This is a growing problem that we need to have some solutions in terms of how we're going to meet the needs of consumer safety, but at the same time of a growing industry.
Absolutely. I actually second Dr. Darin on that one. Given the fact that, food scientists have been looking for ways since, more than 2 or 3 decades on, how to reduce this problem, how to actually reduce the post-harvest losses and the occurrence of this foodborne illness, which is very deadly and has been plaguing the world for quite some time now. And there have been different methods that have actually been developed. So you have physical treatment methods, and these are all high profile, like gamma irradiation and cold storage, edible coating, something that's not very cheap and something that might not be as effective over a period of time, because we have learned from the past, and especially since the time of corona, that pathogens do have a way of mutating and growing on produce. So the moment we introduce a new chemical or a new method of killing or disinfecting a product or sanitizing a product, the moment we introduce a new method, the microbes do have the ability of developing certain sort of resistance. So let's say back in the 1980s, when we used to have problems, we used to just treat it with hot water. But today, when we use hot water on the produce, it doesn't really work because the microbes do know how to counteract and develops resistance. And this has given to the idea, rise to the idea of superbugs. So all these things in consideration, we do have to look at something that's, not costly and at the same time getting the job done. And one of the major issues or one of the major problems that we as scientists are facing today is how to actually reduce the microbial flora and at the same time not cause any kind of problems with the actual produce itself. So we don't want to alter the nutritional profile. So let's say if you're having consuming grapes for the vitamins and antioxidants, we don't want to completely lose those, nutritional capabilities of the fruit, and at the same time not add to any kind of residues that can wreak havoc on the system. So there are a lot of things to take care of, and these days there are only limited amount of solutions that are available that would actually do that.
Great point.
And strong enough to kill the bacteria, and then also still safe enough for the worker that's applying the chemistry as well. Correct?
Absolutely. because these chemical coatings or any kind of treatments that we are going to employ to enhance the shelf life of food or reduce any kind of bacterial load on the product, they have to be handled by people. And most of the times people do require the use of personal protective equipment like headgears, safety glasses, and sometimes they have to completely suit up to use these chemicals in the food. And it is not safe because sometimes in majority of the cases, what do industries do is they, let's say if they're going to chemical treat a produce, they're going to get a concentrated version of the chemical and then cause further dilution. So that's not only unsafe during the transportation, but it's also unsafe for the workers that are handling the chemicals, as well as you never know if it's a manual dilution, whether it's going to be, a perfect, 50 parts per million, or whether it's going to be a little lower and higher than that. So there are a lot of discrepancies that come in the way of it.
So with all the concerns that we're hearing, makes you very gives you some trepidation to continue to eat produce, right? But we're aware of a study that you were part of, Dr. Juhi. Could you talk a little bit more about the chemistries that you tested and what came out of the studies that you performed?
Yeah, so this study we did last year with the university here in Australia, and we actually tested the existing methods that are there in the industry, like ozonated water and sodium hypochlorite, which is just right off the shelf over here. And we also tested ECAS, the electrolyzed water, the acidic electrolyzed water from PathoSans, that's pathocide, and there and different concentrations of pathocide. So what we did was we took different sorts of produce which are very readily spoiled here in Australia and of course around the world. We have strawberries, we have blueberries, and mushrooms. So we did use all these chemicals in different ratios and different quantities and tried to analyze how they affect their nutritional profile as well as their shelf life. Over all the samples that we actually studied, we found that if we use pathocide at a concentration of 80 parts per million, we would be able to actually maintain the nutritional aspect of the produce, reduce the microflora, and at the same time extend the shelf life by approximately 2 weeks at room temperature. And this is when I'm talking about summers here in Australia, scorching heat. So it is actually quite evident with the results that we've gotten that there is a certain aspect to, the active molecule that we generally use in our chemicals or any kind of treatment that is responsible for reducing the microflora on the fruits. And yeah, we haven't never come across the difference between ozonated water and sodium hypochlorite was not very major, but the difference between pathocide and the rest of the solutions was very significant. In fact, this paper has actually been published in Sustainable Food Technology as of this year.
Congratulations. That was really, I've had the opportunity to review that, and it was really an eye opener.
Well, it's
So
necessary. I have always been of the opinion too that the research that we do and any kind of information that we discover or any kind of new innovative approach that we find out, it's absolutely essential for it to be disseminated into the industry as well as to the local people. So anybody who is interested in doing a comparative analysis of what is safe for them today and what is actually, worth spending some money over or worth considering as an alternative to sanitizing or disinfecting. I absolutely believe that they should have all this knowledge with them because today, with the market that's completely focused on, to just kind of have just kind of disseminate any kind of information that's available. I feel it's necessary that people should have access to all information and then choose for themselves what is good for them and what's not.
Well, the other thing too is that you talked about the idea of safe, and I always think of things in terms of like having an asterisk next to it, right? It's safe if you allow time for this to be properly flushed, and but it's safe for the consumer, but early on it's not safe for the people that are handling these chemicals. You got this silver bullet answer, if you will, the silver bullet uh, um, key to your problem, and there's problems with that solution. I have seen situations where there are companies that say, "Well, here is an answer to what we need." Okay, but the environmental impact, or the runoff water, the impact downstream, the impact to the employees, the impact to maybe even the idea of now you're generating all this material that has to be recycled or handled properly. And so you have to kind of weigh all that into the cost of doing X, doing Y, doing Z, doing nothing, in addition to the idea of is it really the right answer for your needs? And this is what the dissemination of this information can help do. In fact, we see so much turnover of people and different capacities within companies. And when you look at the idea of continuity of sanitation plans and what resources are being used, it's important that we don't just have employees that are using things because that's what they're told to use, right? We need to make sure that people are aware, why is this a good solution, or why do we need to have these issues be met? Once we have awareness, then we can have employees that are actually allies, that are supporting we want to use this, we want to be safer, we want to make sure our consumers are safer because of this. And they can end up turning into advocates. We need to do this because of this. They understand the true burden of disease, or they understand the consequences of not following through with the plan or not using the right resources. And I think this is where ultimately you can have the difference between that and that external motivation, that employee that only does it because they're told to, but you can now have people that are internally inspired to use the right solution, to explain to the people they work with, to make sure that the right resources are being used. Once we have that kind of internal inspiration, now we can talk about that long-term continuity of sanitation plans or of using the right resources.
It's
Absolutely.
oh, I'm sorry, Julie. I was
Go for it, Ken.
just going to say great points by Dr. Detwiler, and then also ask you, Juhi, with your study, you had mentioned the brand name Pathoside, but the actual chemistry is hypochlorous acid, correct?
Yes, that's correct.
Right. So with that, as Dr. Detweiler was talking about the safety, is there a need for a final rinse using the hypochlorous acid directly on the produce, or is there a need for any type of personal protection equipment for the worker that's applying the chemistry?
So, no. So, one of the beauties of actually using hypochlorous acid on any kind of surface, even food surfaces, is that it completely, you know, is completely degrades over time. It completely, once it comes in contact with heat or air or sunlight, it completely degrades over time. And with the laws that we have here in Australia and New Zealand, and the concentrations at which we have used the product, so we are allowed to use the product between 25 to 80 parts per million, which, when comes in contact with the microbes, rapidly degrades itself. So here it's a no rinse sanitizer. So you can just dip your fruit as you do in water, and it'll actually do the job. And you can directly eat it after you dried it. And one more thing is you pointed out, Ken, how, hypochlorous acid, how is it safe for workers and whether it requires PPE? Absolutely not. So we have actually handled during our course of the experiments, we were just using it as you use normal water. Like if there was a glass of water and glass of hypochlorous acid just right next to it, you wouldn't even realize it. You could wash your hands with it and you wouldn't feel anything. Like I handle it just like you would, normal water. And that's what I kept saying. It's only as harsh as normal water.
I was going to say it's amazing when you don't really think about these things until you're faced with that situation. I was recently getting work done on my car, and the the maintenance person, I guess, was mopping the floors inside the car dealership, and I don't think she diluted the solution there. It was so concentrated that the ammonia smell that filled the room, they had to open doors and turn on fans. And I think that the idea of think about the impact on that worker who is probably for a very long time been using way too strong of a concentration of this solution. But everyone in that building was like, do we need to evacuate because it's too much?
Wow.
Yeah. No, sometimes you know how people do confuse fumes with a good thing of actually
Right.
being clean. So until and unless they can smell it, or they can feel it, or they can see somebody wearing PPE and handling the product, they're like, oh, it's actually going to work. Why? Because somebody is actually dressed up in all PPE gear just because that's very toxic. But I would actually, through this medium, would like to promote the fact that not everything that you feel works will actually work. So toxicity does not always equal effectiveness. So you can actually achieve that desired level of safety and quality in food as well as in your surroundings without compromising the safety aspect of yourself, your workers, and people around you.
Great points, Julie. And as we like to say, clean has no smell. So we
Exactly.
covered some great topics here today. I think we made a little bit of progress informing the public exactly what we can do with hypochlorous acid on produce and make it safer and cleaner for both the consumer and the handler. So again, that is something that we thought would be good to know. Well, guys, great conversation. Dr. Detwiler, why don't you take us home? Take us recap where we were, where we're going.
Sure, that's a great idea. When we look at what we've talked about today, I see it like this: using the right resources. Here we're talking about production side of things, and we're talking about produce. We can be essentially focusing on environmental, social, and fiscal responsibility of a company, and quite honestly, even industry wide. I think that's paramount.
So I want to thank everybody for joining us today. Looking forward for you participating and tuning in for our next episode. Please take a moment to visit our website, PathoSans.com, and follow us on LinkedIn to learn more. With that, again, we thought this would be good to know.